Alright, so we're looking at solving one easy problem today. Let's take a look at 2 pointers, middle of the linked list. Let's try this one. Given the head of a singly linked list, return the middle node of the linked list. If there are 2 middle nodes, return the second middle node. So for odd number of nodes, you return the middle one. For even number of nodes, you return the second middle node. Straightforward. In terms of understanding the question, let's see how to solve it. Now, we could use a naive approach would be to have a pointer traverse the entire list, get the number of nodes this way, divide that by 2, find the actual node you need to return, then retraverse to find that node and return it. The time complexity of this method would be big O of n. You are performing 2 traversals. Now, is there a way to do this once using 1 traversal? Let's see. Do we know the number of nodes ahead of time? We do not. We are not given the number of nodes. I'm thinking of return the nth element from the back of a linked list. And in that case, what you do is use 2 pointers, one separated by n, let the second pointer reach the end, and your first pointer would point to the node to be returned. Now in this case, we do not know, we don't have that separation n, and we don't know the number of nodes available to us. The middle node of the list is node 3 in this case, and the other one, the middle node of the list is node 4. Interesting. So what if as we move, we keep that pointer behind us exactly halfway up to the element of interest. So if we move up, the first pointer moves up by 1, the second pointer would stay where it is in the first node, then the second pointer moves up by 1, the first pointer moves up to 2 because that's the half point mark. The second pointer moves up by 1, you move it by 1, then finally you move the second pointer by another 1. Now you have 5 nodes, so at that point you can determine if the first node needs to move, so the first pointer. So that would be one method that in a sense would be done with 1 traversal. So you keep updating the first pointer to point exactly halfway through the list, and when you reach the final element, you just return it. Alright, let's try this. Sorry, I got a phone call here. I just muted it. Okay, so the idea is maintain 2 pointers. The first one would traverse the list 1 node at a time. The second pointer would continuously be updated to point to the middle of the list that was traversed so far. Example. So let's write the values for each of the first and second pointer. So let's actually do it in a table format. So let's put second here. So first, let's say first is 0, second will be 0. First points at node 1, second would point at, so what would be the middle of a list of two nodes? The middle of a list of two nodes, is even. What you do is you return the second middle one, so this would be 1. Now let's say this one 2. Where is the second one? Remains at 1. Then 3, so you've got 4 nodes at that point, 0, 1, 2, 3. Which one do you return? You return 2. And then 4, you return 0, 1, 2, 3, 4. So we have this full list, and so you return 0 and 2, you return 2. And then 5, let's look at 5. This is the case in here. Then you return the third element. And then 6, let's say 6. So essentially what you can see, it looks like what we have is divide by 2 for odd numbers. For even number, just divide by 2. For odd numbers, divide by 2 and then plus 1. So divide integer division by 2. In this case, you get 2 and then add 1. So in this case, this is even. Just divide by 2, you're at 3. 7. What you will need to do is 7 divided by 2, integer division, which is 3, and then add 1, so you're at 4, etc., etc. 8 is 4. So what it looks like is this one is moving every clock cycle, if you will, whereas the second one is only moving once every second clock cycle. So here it moves once, stays where it is, moves once, stays where it is, moves once, stays where it is. So this provides an even simpler algorithm. The first pointer moves by 1 every iteration. The second pointer moves by 1 every second iteration. Now, now, can we associate this movement with an index? So the second pointer does not move at index 0. It moves at index 1. It does not move at index 2. It moves at index 3. It does not move at index 4. It moves at index 5. So if we have an index I here, this is where we would have second and first moving. So let's point first is equal to first pointer is equal to second pointer is equal to head. So they're both pointed to head to start with. And what we're going to do is while the first pointer dot next is not null, is not none, or just state this, what are we going to do while we still have an element after us? We will move first pointer by 1. So every iteration, first pointer will be moving. Now, if we kept track of an index, so at I equal to 0, then what you do is you say if I modulo 2, okay, meaning if it's even, we don't do anything. If not I modulo 2, then second pointer is equal to second pointer next. So if I is odd, and obviously we're going to increment I here. So if I is odd, then we will be incrementing or moving second pointer by 1, and the first pointer just keeps moving forward. Now let's test this. If the first pointer were to reach 5, so what index are we at? 0, 1, 2, 3, 4. right? We're index 4. So at that point, this will be the last thing we do because the next while loop will evaluate to false. So we will exit the loop. So the second pointer will have pointed at 5. I, we said, was equal to 0, 1, 2, 3, 4 is equal to 4. So 4, is it even or odd? 4 is even, so the P will not move. So P will not move here. And where was the second pointer then? So, and on odd, we didn't want it to move, right? So when it reaches 4 here, we didn't want it to move, and we wanted it to continue pointing at 2. So this is correct. So then what we do is we just return second pointer. Now, let me just check something. If the second pointer is returned this manner. All right, let's check the edge cases. So the first pointer is not null. The second pointer, let's assume they were both, let's assume the list was empty. What you do is you just return if not first, or if not head. We'll actually just put it here at the beginning. If not head, return head. Okay. If not head, return head. Now, what if we have only one element? If not head or not head.next, just return head itself. In the case of two elements, our algorithm would work. You would increment P the first time, and the second pointer would not be moved, unfortunately. So when you're 1 here, you will have nothing to, so the second pointer will continue pointing. So this is incorrect. We need to handle the case with if not head.next.next, return head.next. Right, so if we have only 2 elements, the rest should be working. Let's try that. So that worked for this. Let's try submitting. It worked. So we can improve on speed, and we'll look into that later. And we've done not bad for memory.